In this video, we will be learning about the electromotive force and the terminal voltage of a battery. So here we have a battery. So we know in a battery that it produces electrical energy using a chemical reaction. So chemical energy is converted to electrical energy. Such a source of electrical energy produces an electromotive force. And we use this symbol to represent the electromotive force. So the problem is, what is the difference between electromotive force and the terminal velocity? Electromotive force is also a voltage and we measure it in volts. So in the battery, we know on the either sides of the battery, where we have the positive terminal and the negative terminal, there is a potential difference. EMF is the potential difference between the battery terminals when current is not flowing to an external circuit. So if I name this terminal A and terminal B, the voltage difference or the potential difference at the two ends of your terminal, which we name as VAB or the terminal voltage, will be equal to the EMF when the current is not flowing out of the battery. In other words, if your I is 0, your terminal voltage is equal to the EMF. However, if your battery is connected to something, let's say this battery is connected to a light bulb, if this battery is connected to something else, if this battery is connected to an external circuit, the voltage across the battery, which is VAB, or the terminal voltage, will not be equal to the EMF. So why? So the main problem we have right now is, why is this happening? So your terminal voltage and the EMF will be different when there is an internal resistance inside your battery. So in other words, batteries or chemical cells are not ideal. They too have some resistance inside them, which we call the internal resistance. Which is symbolized by the simple R. The voltage difference between A and B, so I'll name this point A and name this point B. These are the two ends of your battery, which are the two terminals, is made up of not only a cell or a source of electromotive force, there is also an internal resistance. So this is a diagram of a real battery. When current is actually flowing through the battery to an external circuit, there is a voltage drop across the internal resistor. So the VAB, the voltage at these 2 points, is no longer equal to EMF, but it is less than EMF. So it is EMF minus the current flowing through your circuit times the internal resistance. When your battery is connected to an external circuit, the voltage across your two terminals is no longer the EMF. It is the EMF minus I times the internal resistance. So your actual battery is not just a source of EMF or electromotive force, but there is an internal resistor also inside it. So with this formula in mind, let's go to our first problem. So in this problem, we have a 65 ohm resistor connected to the terminals of a battery whose EMF is 12 volts and whose internal resistance is 0.5 ohms. So let me first draw the battery. So here is my battery, and we know that the battery has an internal resistance. So here's my battery and here's the internal resistor. And I'm going to mark point A and B, which are the terminals of the battery. To the two terminals A and B, they have connected an external resistor, or it's connected to a resistor which is 65 ohms. This is 12 volts and this is 0.5 ohms. 65 ohms, 0.5 ohms and 12 volts. So in part A, they are asking us to calculate the current in the circuit. Using Ohm's law, we know that the voltage drop across a resistor, so we know the current goes like this. Through Ohm's law, we know that the voltage drop across a resistor is given by V equals IR. So this is Ohm's law. So this is our external resistor and the voltage across it is VAB. VAB is given by IR. I is the current through your circuit and R is your resistor. And we just learned is given by the EMF minus current times the internal resistance. So we can rewrite this equation like this. Volts minus the current going through your circuit, I, times R, which is the internal resistance, 0.5 ohms, and the current, I again, and your resistance is 65. So if we solve this equation, we get 65I plus 0.5I. So your I is 12 divided by 65 plus 0.5. So this gives you the answer 0.183 amperes. So in part B, they're asking us to find the terminal voltage of the battery. In other words, they're asking us to find VAB. We know VAB is given by the EMF minus the current going through the circuit times the internal resistor. So EMF is 12 volts. Current, we just found it in part A, it is 0.183 amperes times the resistance times the internal resistance, which is 0.5. So this gives you the answer 11.9 amperes. So here you can see that the terminal voltage, which is the voltage across your battery when a current flows through the circuit, is slightly less than the EMF. So in the last part of the problem, they're asking the power dissipated in the resistor R and in the battery's internal resistance R. We know power is given by the equation P equals I squared times R. So I use this equation because this equation has current and the resistance. So we know current through the circuit and we also know the resistance of both resistors. So we know the capital R and also we know the simple R. So this is the power dissipated through capital R. It is given by I squared. So this is my I squared times capital R, 65, which is 2.18 watts. And power dissipated through the internal resistor is the same equation, but you will be substituting the internal resistance for simple R. So if you substitute the values, you will get 0.02 watts. So you can see here that the power dissipated through your internal resistor is very small compared to the actual load. So let's move to the next problem. So here there are four 1.5 volt cells that are connected in series to a 12 ohm light bulb. If the resulting current is 0.45, what is the internal resistance of each cell, assuming they are identical and neglecting the resistance of the wires? So usually in circuit problems, we always neglect the resistance from wires. So we assume the wires which connects our battery to external, so here the light bulb. So external devices is resistance less. So they say there are four batteries which are connected in series. So it is something like this. So we have this battery. So we have our first cell, we have a second cell, we have a third cell, and we have a fourth cell. And we know they are real batteries. That means they have internal resistance in each of them. So that is why I drew batteries with internal resistance. So each of the batteries, so each of the cells have an EMF. We have four cells which are connected in series, and each of these four cells have an internal resistance. So let me mark the terminals of each of the four cells. So this end is A, this is B, this is C. Let me call this D and this as E. So what can you tell about the voltage difference or the terminal voltage between A and E? So the voltage difference between A and E is the voltage of all of these, right? It is VAB plus VABC, voltage across this cell, so it is VCD, the voltage across the last cell, which is VDE. So the voltage across the 4 cells is the addition of all the 4 voltages. And we also know that these 4 are exactly same. They have said that they are identical. In other words, I can just write 4 times VAB, right? So VAB is the voltage across one cell, the first one. Since all are identical, the addition is similar to 4 times VAB. And we know VAB terminal voltage across one cell is given by EMF minus the current going through the circuit times the internal resistance. So in the problem, they are saying these 4 cells are connected to a light bulb, which is 12 ohms in resistance. So the light bulb is a resistor which is 12 ohms. So we know when it's connected, when your battery or the combination of 4 cells, when it is connected to this 12 ohm light bulb, the current will start flowing through your circuit. Since all of these are in series, the same current will go through your batteries. So if I write the Ohm's law, we know VAE, AE is the two ends that your resistor, 12 ohm resistor is connected to. VAE is equal to I times R. So this is Ohm's law. Ohm's law gives you the voltage drop across a resistor. So voltage drop across this 12 ohm resistor is VAB. VAB is equal to I times this resistor. So VAE we just found out it is equal to 4 times the EMF minus I times the internal resistance. And in the problem, they say that the resulting current or the I is 0.45 amperes. So now we have to solve this equation. So to solve that, first I'm going to get rid of this 4. How to do that? I'm going to divide both sides of the equation by 4. So it gives me EMF minus IR equals to I capital R divided by 4. So as the next step, I'm going to take this to this side of the equation and this to this side of the equation. So EMF minus I R over 4 is equal to I simple R. I will write the rest here. So I will repeat that equation. So I'm going to divide the whole equation by I. That way I can get the value of simple R. So simple R, I'm writing this side first, will be equal to EMF divided by I. So I'm dividing the whole equation by I minus IR divided by 4. When I divide it by I get R divided by 4. So you get the answer as EMF is 1.5. Your I is 0.45. Capital R is 12 ohms divided by 4. So I got the answer as 0.33 ohms. So this is the internal resistance of one of the cells. So this cell will be 0.33 ohms So this internal resistance will be 0.33 ohms and so on. So this is a hard problem. So in our last problem, we have a car battery which is 12 volts. So let's draw the car battery first. So this is my car battery. They say that it is a 12 volts car battery. In other words, they have said that the EMF of the car battery is 12 volts. However, when it is connected to the starter and when the starter draws 95 amperes, the terminal voltage of your battery is no longer 12, it is 8.8. We know that happens when there is an internal resistor in the battery. So let's say these are the two terminals of your battery, A and B, and it is connected to the starter. We don't know the resistance of the starter, but we know the total current which is flowing through the circuit is 95 amperes. So they're asking us to calculate the internal resistance of the battery. So they're asking us what is the simple R. So we know terminal velocity. We know the terminal velocity VAB is given by the EMF minus the current flowing through the battery times the internal resistance. So EMF is 12 volts, it's given in the problem. Current is 95 amps. And the internal resistance is what we are going to find. And VAB, they have given it as 8.8 volts. So they are saying when the current flows through the circuit, the terminal voltage is no longer 12 volts, it is 8.8. So this is the terminal voltage, 8.8. So your R is 12 minus 8.8 divided by 95. So this gives you the answer 0.033 ohms. In the next part of the problem, they are asking what is the resistance of the starter. So to find this resistance, we can use Ohm's law, right? We know Ohm's law gives you the voltage drop across a resistor. So the voltage drop across this resistor is VAB. So those are the voltages at the two ends of your resistor. Why? We know there are no voltage drop across these wires. So whatever the voltage here is same as VA. So this point is identical to point A. There's no voltage drop across the wire. So in the same way, the voltage at B is same as the voltage at this place. So VAB is the voltage across your resistor and is given by the Ohm's law. VAB is 8.8 volts. It's given in the problem, and the current flowing through the circuit is 95 amperes. It is also given in the problem, and your R will be 8.8 divided by 95 amperes. This gives you the answer 0.092 ohms.